Thank you. All right, Hannah, we are starting today, adding to what we learned yesterday on the same page in our comp book. And we're going to be doing some counting techniques right now with conditions. So I can best do that by example. So let's say we're going to count, remember this is counting techniques, all the phone numbers possible, but there are some conditions. Did you know that, what's that called? Not the area code. Isn't that the 410 part?
Yeah.
But the next part, I don't know what that's called.
Oh,
The second set of three numbers. It has a name, but I can't think of it. Cannot start with a 1 or a 0. So how many numbers are there? So as you know, your phone number, it starts out with an area code like 410 or 443 or whatever state you're in. Anyone have a cell phone with three numbers other than 443 or 410? All right, because if you've moved here from somewhere else, you have all kinds of numbers and you don't have to change it, which is nice. All right, so we learned that we can count the numbers. These first three are set for you. There aren't any choices. The area that you live in sets these. So there's only one choice here, one choice here, one choice here. It's assigned to you by your area. When you get to here, I've made a restriction. I said that there cannot be a 1 or a 0 in here. So how many numbers does that leave that are possible? Yes. So there's the 10 possibilities. So when you're doing extra conditions on these problems, you want to count the box with the most restrictions first. This one actually came first, but some examples we do, they won't be in the first position. But you want to go where the most conditions or restrictions are first. So how many ways, Allie, could we fill this box if we can't use 0 and we can't use 1?
7.
Count them.
No.
That's why I wrote them up.
There's a 0.
Yeah, so there's 8. All right. So now, how many ways can we fill in the next box? There are no restriction. It can be any of those numbers. So there's 10. Yeah, and so forth. So when we multiply 8 times 10 6 times, we get what, 8 million?
no, something big.
Something big like that. 8 million numbers.
10 to the 6th.
I think it's 8 million.
10 to the 1, 2, 3, 4, 5, 6 times 8.
Equals 8
Million.
Yeah. 80 million.
No.
No.
Each
8.
10 counts as a 0.
8 million.
Yeah,
8 million.
that's true. That's how I do it. Each 10 adds another 0 to the 8. All right, so I don't want to show you a bunch of these. It doesn't really benefit you watching me do them. So when you come to some later today on the green sheet, on Greenie, with restrictions, just go to the box with the most restrictions and fill that in first. It will help you. All right, let me show you some notation for this, permutations. Permutations are is the mathematical word for arrangements. So this time, write this down. There are 8 horses. And I want to know the number of ways they can come in, number of arrangements they can come in first, second, and third. So I want to first, it's a race. They come in first, second, and third place. How many different ways can that occur? So you have these 8 horses. Horse number 1, 2, and 3, then horse number 1, 3, and 2, horse number 8, 7, and 6, like all these different combinations. So, because there's 3 places, I only need 3 boxes. And how many, this one has no extra conditions. So Molly, the horse person, how many ways can I fill in the first box?
8.
Right. And the second?
7.
Right. This can't be 8 because the horse can't be in first and also second. So once we found the horse that came in first, there's only 7 left to pick for second, and how many ways
6.
is the 6? So what's that? What's 56 times 6?
336.
Thank you. All right, 336. So with that, I want to show you some notation. This can be written, and often is, and you have to recognize it. The permutations, at least we use the right letter. Remember, permutations are arrangements. Can be this very same problem. Can be written like this. And read like not a 6. Where did I get that? There you go. This is read the permutations of 8 objects taking 3 at a time. It matches this problem exactly. So I'll write that out. This is what it's saying. Permutations of 8 objects taking 3 at a time. So I could reduce this, I could remove this from your site, you can no longer see it, and give you this problem. This tells you how many boxes, and this tells you how many choices for the first box. We're assuming there's no repetition allowed with permutations, so it's going to go 8, 7, 6. So let me give you a new one of these and see if you can calculate it just raw. I'll ask you to do the permutations of 5 objects taking 4 at a time. So, see if you can calculate that. Even with no story, in your greenie today, you'll have those to calculate. You need to know what it means. It can show up on an SAT too. They like to throw in things. It's really easy, but if you've never seen it before, you have no idea what it is, you know. So, you're in the elite club now. All right, according to what I just said, Bailey, how many boxes?
4.
4 boxes. So this is 5 objects taken 4 at a time. So if there are 5 objects,
cannot.
how many, what are the numbers, Bailey?
5, 4, 3,
And what's that come out to be?
120.
Very good. You got it? All right, like I told you, today's lesson is a little bit of this and a little bit of that. All right.
Oh yeah, it is. It's not a good song. Yeah, not a good
There is a formula. I don't know if you prefer a formula. I prefer to actually count by boxes, but there is a formula and it goes like this. I want you to have it. The formula is n objects r at a time is n factorial over n minus r factorial. Let's test it for the horse problem and see if it works. So rather than recognizing there are 3 boxes and you start with 8, 7, 6, which I think is a whole lot easier and it adds understanding, I want you to be aware that when sometimes in college they'll say this is how you do it. They don't care about the understanding. So they give you this formula. So let's try it. Plugging these numbers in, Abby, this is the N, this is the R. Plug them in for me in this problem. We're expecting 336.
8 factorial.
Over.
8 minus 3.
All right. So 8 minus 3 is a 5 factorial. And that's why I taught you to do those without a calculator, because I knew this day was coming. Everything I teach you has a day that's coming. So don't think it's all for nothing. All right, so we ended up with 876, didn't we? Remember how we did that? We kept our eye on the prize. We expanded 8 factorial until we got to 5, crossed them out, and it left the same thing. So, you have that formula now? All right, how many minutes do you think I've taught? Why don't you just stop it and start it again? Bailey, stop it and start it again. I'm not sure how long I've